set up for us nicely to just do substitution. I'm going to substitute maybe y equals x plus 4 into the second equation for y. So instead of writing y here, I'll write x plus 4. So I'll get x plus 4 equals 1/2 x plus 1, like so. And so now I just need to solve for x. So I'll subtract 1/2 x from both sides. That'll leave me with 1/2 x plus 4 equals 1. Excuse me. I could subtract 4 from both sides. I'll do that. That'll leave me with 1/2 x equals -3. And then I would just multiply both sides by 2 to get rid of this 1/2. And it turns out x will be -3/2. So x is -3/2. Now that I know x, I can go back and find y by just plugging x equals -3/2 into one of these two equations. It doesn't matter which one. I'll just take the first one. So y will equal -3/2 for x plus 4. And -3/2 plus 4, let's see, I'd have to write 8/2, so 5/2, maybe? Huh.
Shouldn't x be equal to -6?
Oh, yeah, thank you. I divided for some reason in my head. Yeah, my bad. X is -6, so this y made no sense. I was thinking it made no sense of our picture. X is -6, and so I plug in -6 for x, so I get -6 plus 4, and so I get -2, and that makes more sense with our picture to have a negative y coordinate. So thank you very much for calling that out. X is -6, y is -2, so that's our coordinates here. -6, -2 is this quarter point. Okay. We'll do another one. Let's find, I don't know, how about this corner point next? So we do the same thing. I'm going to take the two equations for the lines intersecting at that point. So here I have the blue line and the red line intersecting. So I need to take those two equations and put them in a system. So my system will be y equals x plus 4 for the red line, and then the blue line is y equals -5/2 x plus 5. So here's my system to solve for this corner point. And so I just do the same thing I did before. I have y equals x plus 4. I can substitute that for y down here. So I get x plus 4 equals -5/2 x plus 5. And now I can solve this for x. If I were to add 5/2 x to both sides, I think over here I'm going to get 7/2 x. And if I subtract 4 from both sides, I'll get 1. So I think 7/2x equals 1. And so I think x, again, is 2/7. If we were to divide by 7 and multiply by 2 on both sides, I should get x is equal to 2/7. If I did this correctly, which I think I did this time. So it looks like x is 2/7. Now I'll take this and plug it into one of these equations. So maybe y is equal to 2/7 plus 4. Oh boy, let's see, is that 30/7? I'll get 28/7 for 4. Yeah, it looks like 30/7. So y is 30/7. So that's just some gross fraction. I don't know. You can't reduce that fraction anymore, so we'll just leave it that way. So our coordinates are 2/7 and 30/7 for this guy up here. Again, I'm glad we did it. We have a method for finding this exactly, because maybe I could eyeball -6, -2 if I drew the graph well, but there's no way I would ever eyeball 2/7 and 30/7. There's no way. Okay. Finally, we could find this one quick. I might as well just do it for completion's sake. We'll find this other one. Probably good for me to do a complete total example. So there I have the blue and the purple line intersecting. So we'll take those two equations. Blue and purple. That's y equals 1/2 x plus 1, and y equals -5/2 x plus 5. So let's solve this. Again, just substitute down here for y. Get 1/2 x plus 1 equals -5/2 x plus 5. And now we'll just solve this out for x. So I'll maybe add 5/2 x to both sides. I think we'll get 3x. 5/2 plus 1/2 is 6/2, which is 3, so 3x. And if I subtract 1 from both sides, I'll get 4. So I think x is 4 over 3. 4 over 3. And then finally, we just substitute this in again, and I'll find y. So y is equal to, pick whichever one you want. It doesn't matter. We'll do the first equation. So that's 1/2 times 4/3 plus 1. So y is equal to, let's see, 2 over 3 plus 1. So I think y is equal to 5 over 3. So these coordinates, it looks like, is 4 over 3 and 5 over 3. Again, we won't want to eyeball those. We want to find them exactly, so we do it this way. And there we go. We found all 3 corner points. So it's a bit involved because you do have to solve out all these systems to find, I had to solve 3 systems to find the 3 points. But it's the kind of thing where, again, if you solve them all in the slope-intercept form, that's sort of a shortcut. It makes for the substitution to be a lot easier. Otherwise, you could write them in a different way, maybe try to do the elimination method or something, or if you really wanted to, you could use a matrix. Any of our methods for solving a system of equations will work. But in this case, I like to just put these in slope-intercept form and then use substitution, because I think it's nice to have them in slope-intercept form to graph, and then it makes the substitution nice as well. So that's my bit of advice, is solve these in the slope-intercept form. Okay. Were there any other questions? Okay. Yeah, if not, I have one fact to tell you. That at least in this class, we can always basically assume that this thing is this is true. We can basically just assume that this is true. If a system has n inequalities, so if we're graphing a system of n inequalities, so n is just some positive number, whole number, then there are at most n corner points. And I'll put in quotation, usually exactly n corner points. So if I give you a system of three inequalities, probably there's going to be 3 corner points. If I give you 5 inequalities, there will probably be 5 corner points. Strictly speaking, there could be less than. I could give you a system of 5 inequalities and there's only like 3 corner points. But that would mean that a couple of those inequalities were or in a sense, they were redundant. I basically didn't need to include them. And so I think most of the examples that you see in this class, that won't happen, and it'll probably match up exactly. So I think in most of your examples, if I give you n inequalities, there will be n corner points. But strictly speaking, there might be some weird examples where that doesn't quite happen and you get less corner points. But anyway, this is sort of a good sanity check when you graph these out. If you're graphing 4 inequalities, you should check and see, do I have 4 corner points? If you have less, that might not mean anything because of this. But if you have more corner points, then you have a problem, right? So if you graph 4 inequalities and you have 5 corner points, something went wrong and you need to go back and check your work because you should not have more than 4 corner points. Okay. So I want to leave. That's something that I got reminded of and wanted to tell you. Otherwise, now I have nothing more to say. So unless there are more questions, then I'm done talking for today, I think. And we will spend the rest of whatever time, how much time is left? 20 minutes. So we can take the remaining 20 minutes for you guys to work on the 7.2 activity some more and ask questions. So we will do that.